Well, if you miss it, we're just going to talk about the voltage required to produce a current of 1.2 amps with a load, in a load with a resistance of 250 ohms. So it's really kind of simple. The starting equation you want to work with is, there we go, V is equal to I times R. In other words, voltage is equal to current times resistance. And of course, we could rearrange that to, like, for example, solve for currents. And all you have to do then is just divide both sides by resistance. And so current is V divided by R. And if you want to solve for resistance, well, just divide both sides by current, where resistance is voltage divided by current. And those are the three equations I pretty much always have written at the top of my paper or top of my notes whenever I'm trying to solve questions like this. So for the first question here, we have a current of 1.2 amps. That is going to be my current. And we have here a resistance of 250 ohms. That little ohm, that little Greek letter omega is our clue that it is resistance. So what I'm going to do here is I'm just going to list my knowns and my unknowns. Current is 1.2 amps and resistance, I know, is 250 ohms. And I'm trying to find the potential difference. And another word for potential difference is voltage. Okay, so voltage, electrical potential difference is going to be my big question mark. Okay, so now I've got this set up. I would like to now decide which equation should I use. Well, obviously it's going to be the first one, the main one, the starting one. They're all the same. There's no main or starting, but just the way I wrote it. So this is going to be V is equal to current times resistance. So all I'm going to do is plug that in, velocity. Every time I do that. Voltage is current, which is 1.2 amps, times the resistance, which is 250 ohms. And when I solve for that, voltage is going to be 300. And you might wonder what the units are. Amp ohms? No, that's not really how it works. The voltage, it does work out if you know what all the, but doesn't really matter. The ampere is volts, of course. So the voltage is 300 volts. So that's all there is to it. Now, I have another example here. We have another circuit. We have a resistance of, well, it says 50 of resistance. And that is ohms. Okay, that is, again, the Greek letter omega. That is going to be my resistance. We want to know what is the current it's going to draw. So what current is going to be my I, my current? And we have 110 V. Well, that's very obviously going to be V. So for my second question here, I know that resistance. Well, I could just kind of do the same order as I did above. It doesn't really matter. I like to be consistent sometimes. That was a joke. And so my current, my I, is going to be the question mark for the second one. My resistance is going to be 50 ohms. And my voltage is 110. Whoa, I almost wrote volts or ohms again. Let's just delete that really quick, pen. So now I want to solve for current. So which one do I use? Well, I don't have to rethink it because I wrote it down at the top, just like I said I always do. So I know that current is equal to V divided by R, voltage divided by resistance. So if I plug my numbers in, voltage is, in this case, 110 volts. And resistance is 50 ohms. And current is, if I divide that out, my calculator shut off on me, 2.2 amps. Okay, so once again, current is amps. So I'm going to stop the video right there because I think that should do it for you. Let me know if you have questions.